Hello, welcome to another Cracking the Cryptic puzzle in the Wall Street Journal series. And this is for a puzzle appearing on the 20th of December called Hidey Hole. And in this puzzle, it's a killer Sudoku puzzle with cages that... So first of all, we have normal Sudoku rules. 1 to 9 must appear in every row, every column, and every 3x3 box. In each cage, the cage sums to the total shown and mustn't have a repeat digit in. So those are the standard rules of killer Sudoku. Let's get cracking on this puzzle and see how we would go about solving it. So we've got a few cages that are kind of, we know what the cage must consist of. A 16 cage has to be a 9-7 pair. There's no other way of making up a 2-cell 16 cage. Then we're going to look down at this 14 cage, which now can't have a 9 in it because the 9 in the column has gone. So this is a 6-8 pair. And now we're going to use one of the techniques that we are becoming more and more familiar with in killer Sudoku, and that is the rule of 45. Every row, column and box in a Sudoku always adds up to that digit, to that number, 45, because it's the sum of the digits 1 to 9, and by rule they go in every row and column. So for instance, rows 9 and 8 must add up to 45 plus 45 equals 90. So if we add up the cages that constitute that area, we can subtract 90 from the total and we'll know this digit. And these cages add up to 23, 33, 41, 55, 75, 98. So 8 is the digit left over. The same is true about rows 1 and 2 and that cell. So these add up to 24, 40, 52, 60, 91. So that digit must be a 1. This cage adds up to 31. And it's already got a 1. The other 3 digits that add up to 4 digits that add up to 30 must be 9, 8, 7, 6. We've already had an 8 in this column. In this box, to get to 8, we now must use 3 and 5. The digits remaining are 2 and 4. 4 can only go in the 13 cage, because otherwise you'd have 4, 4 in the 8 cage. 2 can only go in the 8 cage, because otherwise you'd have 2, 11 in the 13 cage. So that gets us digits poking into the next boxes. Here in box 6, we've got 2 13 cages. Now there are 3 ways of making up 13 in 2 digits. They're 6, 7, 5, 8, and 4, 9. Well, neither of these can be 4, 9, because we've had a 9 in the box. So they must consist of 5, 6, 7, and 8. 8 is looking at those cells. So these ones can't contain 5, which are actually being looked at by a 5 up there. But anyway, we found a quad of 5, 6, 7, 8. That means this cage can't contain 5, 1. So it must be 4, 2. We're left with 1 and 3, and this 6 cage can't have a 3 in it, because both digits would then have to be 3. And that would break the rules of Sudoku. Right, let's add up box 9, which we know adds up to 45. We've got 23 plus 10 is 33. Plus 5 is 38. This must be a 7 to get us to 45. And that's going to leave these not being 7s. That means these aren't 6s. And in this column, we're left with 1 and 9, which do make up a 10 cage. These digits must be 2, 3, 4, and 6. That 4, 3 pair shows us which way round they go. This 2, 6 pair and 9 takes 6 and 9 out of those cells, and that 7, 8 pair takes 7 out of those ones. Now let's go across the row. Again, using our sum of 45, we've got 9, 17, 22 there. Plus 17 is 39. That leaves over 6. So we get a 6 here and a 3 above it in this 9 cage. Now, this is going to contain 1, 3, 4, 7 in some order. I'm not going to pencil mark that. I'm going to look at this row. So 6, 2, 1, 4 adds up to 13. Plus 24 is 37. This digit is 8. Then we get a 4 below it in the 12 cage. 8, 4, 3, 6. Okay, this 12 cage doesn't have a 9 or a 7 in it, so that must be an 8, 4 pair. And now these digits are 3, 5, 7 and 9. Well, the 7 and 9 can't go in this box, which has already got its 7 and 9. So they go here. This is a 3, 5 pair. These digits are 1 and 2. And that leaves us in a bit of a dilemma, because a 12 cage in 4 digits is either 1, 2, 3, 6 or 1, 2, 4, 5. But we haven't therefore resolved which way round this goes. What we do know is that in row 1, we've only got one more digit from 1 and 2 to go. And this cage needs 2 of them. One can go in there, but the other one has to go here. So that's what I'm doing there. Then I'm going to look at, how about the 26 cage? Does it have to have a 9 in, is an interesting question. The answer is no, because you could make it by adding up 8, 7, 6, 5. So we can't be absolutely sure it's got a 9 in. And I don't know how to deal with that yet. In this row, we've got 1, 3, 4, 9 to place. I can't do this cage yet either, actually, because it's either 1, 7 or 3, 5. Maybe we could think about the digit 1, which can't go in those cells. It's either in the 8 cage or it's sitting here. I'm not sure what that's going to tell me. Okay, maybe I'll think about these and whether they can be 4, 5. That would leave 8, 3, 7, 9, 6, or 3, 6. That would leave 5, 9, 7, 8, 4. Yeah, both of those work. I'm not sure what to do. Okay, let's look at 4 then. 4 and 4. We need a 4 in row 6. It can't be there because of this 4, 8 pair. So it's in one of these cells. 3 and 3. We need a 3 in row 4. Could be anywhere there. We know that the 29 cage doesn't have 3 or 4 in it, but it's got 5 cells in it that do add up to 29. Imagine the string of digits from 1 to 9 adding up to 45, and take out the 4 and 3. Then you've got 1, 2, 5, 6, 7, 8, 9, and they add up to 38. So we've got to remove 2 digits that add up to 9 from 1, 2, 5, 6, 7, 8, 9. Well, that means we're not going to remove the 9. We are going to remove 1 or 2, along with 7 or 8. And the other digits are going to have to go in here. Well, that's going to have to include 9, 6, and 5. So this cage is going to have to include a 9, a 5, and a 6 somewhere in it. The 6 actually can't be in either of these cells. The 9 can't be there. But 9, 5, and 6 are in those cells, and they all see this cell in the puzzle, which also sees 4, 2, and 3. So that's 1, 7, or 8. We can rule out 1 straight away, because this cage would need more than the maximum digits that could go in it to achieve 26 if that was the case. So that is 7 or 8. And that is going to be one of the digits that is missing from this cage, along with 1 or 2. This digit is going to be the other one, because that also sees 4, 2, 3, and all the digits in this cage. So that has to be the other digit that is missing. That has to be 1 or 2 as well. And it can't be 2. So that must be a 1. This is 8. These are now 9, 5, 6, 7 in some order. They add up to 27. And this must be a 2. And now we can add up this box. We've got 10 there, 26 in the L-shaped cage. That's 36. This digit is a 9. And now we can proceed to fill the rest of the grid. 1 there has made this a 2. That sorts out 1 and 2 up there. We've got a 5 here. It sees every other possible Sudoku digit in its column or box. 7, 9 pair here. 5, 7, and 6 still to go. Now, this cage needs 1 and 4. This one needs 3 and 6. And they're going to resolve all of the rest of the row. well, no 6 here, no 6 or 7 here, 6 because of that pair, so that's a 5, and then that sorts out 5, 7 and 6. This cage has had to become 3, 5 at this stage, then we can fill in 9 and 1 here. This digit is a naked 4, it sees everything else including that 6, 8 pair. We've got 2 to place in this box, then we can do 3 and 8. The 8 is amongst the things that sort out 6, 7 and 5, 8 in the 13 cages. Then we can do 6, 7 and 5, 6 and 3. Now in this column we can do 3 and 5 now. This digit must be a 1, it's all that's left. Then we need a 4, 7, 9 triple. Now in this row we need 3, 4 and 9. That digit has to be a 4 and that sorts them all out. Got an 8, 5 pair here and a 1, 2 pair here. Now let's think about the math. 16, these two need to add up to 7. They must be 2 and 5. And that is going to resolve rows 8 and 9. I nearly called them 9 and 10 there. We don't have a row 10 in Sudoku, ever. This is 7, 4. They're not fixed yet. 3, 5 are, 3, 4. Then we can do 7, 4. Then we can do 7, 9, and I've got all 4, 1 left at the top, and there's Hidey Hole solved. And that is another of our Wall Street Journal puzzles. Do tune in for more. Look for the playlist of Wall Street Journal puzzles in Cracking the Cryptic, and you'll see how to solve the puzzles that have appeared in the paper. Bye for now.